Thanks for joining us today on this training session about UV and its benefits for building occupants and homeowners' family members. In the next 20 minutes, we will be talking about the UV benefits and how Sanuvox, a North American leader in UV surface and air disinfection, will help you make money while helping others breathe better. Sanuvox is a Canadian company founded in 1995 by Dr. Norman Bray, PhD in nuclear physics. Over the last 24 years, we have been developing 20 different unit models to improve IAQ in residential, commercial, and health institutions. The company holds several patents and is the only company that has ever been published in a medical journal, The Lancet. Today's agenda will cover the following items: indoor air quality, the germicidal effect of UVC, UV found in natural outdoor environment, the UV dosage that should be applied inside homes and offices. We will then look at the different models servicing the residential market, and conclude with safety concerns and independent studies. It is a fact that 1 cubic feet of air per person allows human beings to stay alive. We are like a small machine where we consume sugar and oxygen and release 1 unit of energy, carbon dioxide, and water vapor. The history of ventilation inside buildings shows that the first to acknowledge the concept of CFM was a scientist by the name of Treadgold, who determined that 3 CFM would be a minimal amount of air circulating in a building to keep all of us awake and alive. In 1893, due to a tuberculosis outbreak, a second scientist raised the level of CFM to 30 and 60, where TB patients would be quarantined. In 1915, 21 U.S. states set the guideline for air recirculation in buildings to 30 CFM. However, the first petroleum crisis hit in 1973 and ASHRAE brought the level back to 10 CFM in order to reduce energy consumption and save money to building owners. The second energy crisis hit in 1981 and ASHRAE reduced once again the CFM to 5 per person. 150 years later, the industry leaders in heating and ventilation got us back to where one scientist in 1824 had set the first standard. Thankfully, that level was raised to 15 back in 1989, which means that a lot of homes and buildings were built under the old lower standards, and that even today with our new constructions that are as airtight as they can be, we have an IAQ problem. Here's what's in the air we breathe. Here is what else we find in the air: solids with pollen, particles, and dust. Chemicals with VOCs, solvent, formaldehyde. Biologicals with virus, bacteria, and mold. Bacteria is a source of odors, 2 very good examples being perspiration and bad breath. When we rinse our mouth or apply deodorant in the morning, if we read the label carefully, you will read antibacterial product. Hence, if we walk into a building or inside a house and the smell is bad, we can acknowledge that the air we breathe isn't that good and most likely contains a high level of bacteria, viruses, and mold. Can we control odors with more ventilation? Certainly, but at the expense of increased energy costs. Reheating the air in the winter in the northern states after you have opened the windows is costly. Recooling the air in the summer in the southern states after you have opened the windows is also very expensive. Thus, we close the windows, we seal the doors to prevent any leakage, breathing the same stale air again and again, leading to headaches, allergies, health-related symptoms, and more. Then how can we control the level of bacteria, viruses, and mold indoors? The question is, how is it controlled outdoors? And the answer is the UV rays from the sun. Bacteria reproduces exponentially, unlike humans who will have 1, 2, or 3 children over a lifetime. Bacteria reproduces such as 1 becomes 2, then 4, then 16, then 256, and so forth. In a very short period of time, hours or days, the level of bacteria increases indoors beyond the level of protection that people with a weaker immune system have, leading to health problems. The DNA of any living organism is very sensitive to radiation wavelengths found between 250 and 280 nanometers. All visible light we see is 400 nanometers, and all UV wavelength is found below that range. This graph shows the peak of efficiency to break the DNA of any living form, and that is about 264 nanometers. This is a small recap of wavelength. Over 700 nanometers, we are in the infrared band. Between 400 to 700 nanometers, we are in the visible light band. And below 400 nanometers, we are in the UV band. We can categorize 4 types of UV. UVA is what affects your eyes when looking at the sun. A good pair of sunglasses will protect you against these rays. UVB is what will get your skin to tan. When exposed to these rays for a period of time without the application of a good sunscreen lotion, your skin will change color. These 2 types of UV, A and B, are what purify the atmosphere of the Earth. Indeed, on an average day of 12 hours of sunlight, any airborne contaminant receives a dosage of UV A and B and is thus sterilized beyond reproduction. The UVC is a wavelength that doesn't penetrate the Earth's atmosphere. They stay in the stratosphere, and Sanuvox uses them to sterilize and disinfect the air inside homes and buildings. Inside the air handler, we do not have the luxury of time. The air molecule moves at a speed varying from 400 to 1000 CFM, and as such, we need to use a lethal dose much greater in power. Here we use the UVC. The UVC will perform in a fraction of a second of what UVA and UVB will do over 12 hours of sunlight. The UVV is the 4th wavelength that is used to eliminate odor. We asked ourselves before making any product what the average dose of UV is received on the surface of the air on any given day. A simple math equation gives us an average of 19,189 microwatts. Seconds in centimeters square, also called joules per square centimeter. Let's do a quick recap. UV type C is germicidal and acts on the DNA to inhibit reproduction. UV type V is an oxidation wavelength and completes a chemical reaction to reduce odor levels. Based on these findings, we can now start making UV disinfection units to sell to the public and building managers. We find it important to have gone through these first 20 slides to have established the basis of our arguments. We can't sell something that we are not familiar with. As customers get more educated, they ask questions, and we hope that these previous slides will answer their questions or concerns about our products and technology. This slide presents a variety of bacteria, viruses, and mold to show that not all living organisms have the same tolerance to UVC. Therefore, before we manufacture units, we need to consider the most difficult one to neutralize and design units that can destroy all the easiest ones after attacking and neutralizing the toughest one. Where does UV now fit in the fight to improve indoor air quality? Filters capture particles, something UV can't do. UVC lamps neutralize anything that will pass through the filters by breaking its DNA and inhibiting its reproduction system. Much better than chemical products and without the chemicals' side effects. UVV reduce odors at a much lesser cost than the expensive charcoal filters without the pressure drop associated with these types of filters. The reason we need to bring UV inside our buildings is because window panes are barriers to UV rays. As much as they let the visible light penetrate, the invisible light, the UV, can't come through. So the same air recirculates without the positive effect of UV disinfection. Sanuvox approaches the IAQ in 2 different ways. We can sell and install lamps inside the HVAC duct that treats the air, and we can also sell and install UV system inside the HVAC unit to shine on the evaporator coil, cleaning the object. Both units are designed and installed differently. The air unit has the lamp parallel to the airflow to maximize the time of contact between the UV lamp and the air molecule, while the surface disinfection unit has the lamp mounted perpendicular to the airflow and shines 24/7 on the cooling coil to prevent mold buildup. 2 factors come into play to maximize the unit's efficiency in improving air quality: time of residence and intensity. The orientation of the lamp parallel to the airflow allows for a longer residence time between the UV rays and the air molecules. The intensity of the source, combined with reflectors inside the unit's lamp chamber, results in a high-intensity area where the lethal dose is delivered to each biocontaminant. Therefore, the UV dose is calculated by multiplying intensity and time. If we can deliver a greater dose than what is needed to break the DNA, reproduction code of the contaminants, we consequently improve air quality by lowering the concentration of contaminants. There is a rule with UVs, and that is the 2-inch rule. Whereas 90% of the UV lamp intensity is found within 2 inches around the lamp itself, the air molecule that moves away from these 2 inches receives a very low dosage of UV. This is especially important when we recommend a unit or another. Straight lamps installed perpendicular to the airflow not only give very little dosage to the moving air, but have a limited outcome to the air passing more than 2 inches away from them. However, the air moving parallel to Sanuvox G lamp inserted in a tube sees the air molecule receive a massive dosage of UV for a longer period of time. However, the air moving parallel to Sanuvox J lamp inserted in a tube sees the air molecule receive a massive dosage of UV for a longer period of time. Here are the two types of UV systems: air disinfection units and surface disinfection units. The first one achieves great results by improving air quality in the house, while the second one does a fantastic job at keeping the cooling coil clean from mold and biofilms. The Sabre Pro is not better nor worse than any other product sold by the competition. A straight lamp is a straight lamp. They all emit at the same frequency, offering the same benefits, which is to clean the coil. The advantage of the Sabre Pro is that Sanuvox offers a remote control that can be installed anywhere in the house and give the homeowner an instant view of the unit's operation. It also includes a day counter that will start at 365 days and will resume to 0 when lamp is due for change. A message will appear at the bottom of the display telling the homeowner to change lamp and call an installer. What a great way to support the sale of replacement lamps and increase your sales! Note that the message can be personalized with your name and phone number upon request. The Sabre Pro is also sold with a second lamp at no charge. You may choose to keep the lamp and sell it off in a year or use it to promote the sale of the unit to customers by giving it to them at the time of purchase. Lamps have a 1-year warranty. The SR Max and R Max are the only true UV air purifiers on the market. These are the only models where the lamp is mounted parallel to the airflow. The units are sized by the square living space in homes. The SR Max is ideal for homes up to 2,000 square feet, and the R Max is the preferred models for home up to 4,000 square feet. The lamps are not only germicidal but also offer an oxidation process. Odors, VOCs, and other chemicals are eliminated with the oxidation section of our UVC UVV bulb. Both units and bulbs are warranted for 3 years on both models. Sanuvox also offers self-contained units. Here we have the Sanuvair S300 and the Sanuvair S1000. Each unit is equipped with a fan motor delivering respectively 300 and 1000 CFM. A high-intensity UVC and UVV bulb does an excellent job in improving air quality and removing odors. The Sanuvair S300 is installed in homes, but also in garbage rooms, gym locker rooms, and daycare centers. The Sanuvair S1000 is installed mostly in larger facilities where the air needs improving. Sanuvox offers a unique portable unit made of metal. The unit uses the same UV lamps as the SR Max and covers a surface up to 900 square feet. It is ideal for condominiums, boats, RVs, or small apartments. The unit has a full 3-year warranty, including the lamp. For those of you who deal with commercial clients, we offer a Bio Wall and Quattro. These two units are installed parallel to the airflow and fit any AHU from 2,000 CFM to 100,000 CFM. A proprietary sizing software is used to calculate the kill rate of the targeted contaminants. Please contact your local Sanuvox representative for more information. Note that UV destroys plastic that is in line of sight, and it is dangerous to look directly at UV lamps when they are lit. Refer to the caution notice in the installation manuals. You will find many independent studies on the Sanuvox website under the login section. Sanuvox is the only UV manufacturer ever published in Lancet Medical Journal. To emulate outdoor conditions to make healthier buildings, ventilation has been used to control CO2 level. To control airborne contaminants, UVC is the most effective solution.